In the following video, we're going to practice scalar multiplication of a matrix. Now, scalar multiplication of a matrix relates to the distributive property. So when you're doing scalar multiplication, what you want to do is distribute the number that's being multiplied to the matrix to every single number inside the matrix. So it's just like the distributive property. You're going to multiply in the scalar value to every single number. And so if I'm doing scalar multiplication with the first matrix, I'm going to distribute a -3 to all the terms. And so that's going to give me, -3 times -2 is a +6. -3 times +2 is a -6. And -3 and 9 is -27. Now do the bottom row, -3 and 5 is -15. -3 and -6 is a +18. And then -3 and 8 is -24. And so this is the final matrix after we do our scalar multiplication. So when you do scalar multiplication, just in your mind relate it to the distributive property. Take the number on the outside and bring it into all of the numbers inside the matrix. So we can do it for the second example as well. The -2 is going to be multiplied to every single number inside the matrix. So -2 and 5 is -10. -2 and -7 is +14. -2 and 1 is -2, and -2 and 4 is -8. So this row is -2, -8. -2 times 0 is 0, and -2 and 9 is -18. And so after doing the scalar multiplication, I get my final matrix. And so we can examine that when we do our scalar multiplication, it does not change the dimensions of the matrix. In this matrix, remember, matrices dimensions are rows by columns, so 2 rows by 3 columns. And when you distribute in, you're going to keep the same dimensions. So we can see that scalar multiplication does not change the dimensions of a matrix. 3 rows, 2 columns, 3 rows, 2 columns. So just relate the idea of scalar multiplication to how you have used the distributive property in the past.